Imagine that all of humanity, every city, every civilization, every language, every war, every discovery, every book, every child, every one of us might never have existed. Not because of war, not because of disease, not because of an asteroid impact, but because of a single event that happened long before recorded history, 74,000 years ago, at a time when there were no nations, no writing, no memory of the past. Back then, only a few 100,000 humans lived on Earth, small groups scattered across Africa and partly across Asia. They did not know the word civilization, but they already had language, they already had families, they already had children, and they were your ancestors. Yet at some point, all of it may have nearly ended. Some scientists believe that around 74,000 years ago, the population of Homo sapiens declined dramatically, so dramatically that only a few thousand individuals may have remained, possibly even fewer. If this is true, then every person alive today descends from a tiny group of survivors. We are not simply a species that evolved, we are a species that almost vanished. And according to one of the most debated hypotheses, the cause was a supervolcano, the eruption of TOBA, one of the largest volcanic events in the past 2 million years, powerful enough to alter the climate of the entire planet. But was this truly a near extinction of humanity? Or is the story more complex? Science does not offer simple answers. Genetics suggests one possibility. Archaeology sometimes suggests another. Climate models offer yet another perspective. And between these interpretations lies a question that reshapes how we understand ourselves. Did we survive because of strength, because of chance, or because we happened to be in the right place at the right time? To answer that, we must return to a world completely unlike our own. A world without cities, without borders, without history. A world where every day was a struggle for survival, and where a single volcano may have changed the fate of our entire species. Today we will explore what the world was like before the eruption, what happened during the explosion, how the planet changed, what our DNA reveals, and whether humanity truly passed through a genetic bottleneck. Because if this story is true, then we are the descendants of those who survived the most dangerous moment in our species' history. And perhaps it was then that the true story of humanity began. This is not just a story about a volcano. This is a story about how fragile human life is, about how close we came to extinction, and about how every single one of us living today is a miracle, the result of incredible luck and the survival of those who lived tens of thousands of years ago. Think about the scale of what we are discussing. In our modern world, we worry about many things: economic crises, political conflicts, climate change. But 74,000 years ago, humanity faced something far more fundamental: the very real possibility that our species might not continue, that the experiment of Homo sapiens, barely 200,000 years old at that point, might end, that the unique combination of intelligence, creativity, and adaptability that makes us human might vanish from the Earth forever. And yet, here we are, 8 billion strong, on every continent, in every climate, speaking thousands of languages, building cities that touch the sky, sending probes to other planets. How did we get from a few thousand desperate survivors to this? That is the real question. That is the story that makes us who we are. That is why understanding the TOBA eruption matters, not just as a piece of ancient history, but as a window into the resilience and determination that defines our species. So let us begin this journey. Let us travel back 74,000 years. Let us see the world as it was. Let us witness the catastrophe. Let us understand how our ancestors survived. And let us discover what this ancient story tells us about ourselves today. Before we dive into the details, let me set some context about why this story matters so much. This is not just ancient history. This is foundational to who we are. When we look at human history, we tend to focus on the recent past, the rise of civilizations, the development of agriculture, the invention of writing. But these are all recent developments, just the last 10,000 years. Before that, for hundreds of thousands of years, humans lived very differently. Understanding that deep past, understanding moments like TOBA, gives us perspective on what it means to be human. on what our species is truly capable of enduring. And there is something else. In our modern world, we have become somewhat disconnected from nature. We live in climate-controlled buildings. We buy food from stores. We are insulated from the raw realities that our ancestors faced daily. But TOBA reminds us that nature is powerful, that the earth we live on is not a stable platform, but a dynamic, sometimes violent system, and that human survival has never been guaranteed. It had to be fought for, earned, won through determination and adaptation. 74,000 years ago, Earth was a completely different planet. An ice age was in full swing. Massive glaciers covered North America, Europe, and parts of Asia. Sea levels were 120 meters lower than today. Entire continents were connected by land bridges that no longer exist. The world map you know would be useless. Indonesia, Malaysia, and much of Southeast Asia formed a single landmass that scientists call Sundaland. Australia and New Guinea were also connected, forming a continent called Sahul. The Bering Strait between Asia and North America was dry land, a wide bridge that would later allow humans to reach the Americas. Britain was not an island, but part of continental Europe. The Mediterranean had different coastlines. The Persian Gulf was mostly dry. This was a world shaped by ice, but not everywhere was frozen. The tropics remained warm. Africa, though drier than today, still had savannas, forests, and lakes. South Asia, Southeast Asia, these regions were lush, though different from their modern forms. And it was in these warmer zones that most human life existed, because 74,000 years ago, humans had not yet conquered the cold. We were still a tropical and subtropical species. But here is the most important fact. Earth was home to multiple species of humans, not just Homo sapiens. Neanderthals inhabited Europe and Western Asia. These were robust, muscular people, perfectly adapted to cold climates. They had large noses to warm, cold air, massive bodies that conserved heat. Their brains were actually slightly larger than ours, though structured differently. They made sophisticated stone tools. They controlled fire. They buried their dead. They were intelligent, capable, successful. In Asia lived the Denisovans, a mysterious species we only discovered in 2008. We know about them mainly from DNA because fossil remains are scarce. Just a few teeth, some bone fragments. But genetics shows they were real, and that some modern populations, especially in Melanesia and Australia, still carry their genes. Who were they? What did they look like? We are still learning, but they were there, living in the mountains and caves of Siberia, maybe in Southeast Asia too. On the island of Flores in Indonesia lived Homo floresiensis, nicknamed the Hobbit, standing about 1 meter tall, with a tiny brain, but capable of making stone tools and hunting dwarf elephants. They were survivors, living on an isolated island, evolving in their own unique direction. There may have been other human species too, ones we have not yet discovered. The fossil record is incomplete. Every few years, new discoveries change what we thought we knew, and among all this diversity was Homo sapiens. Us. Our species emerged in Africa roughly 300,000 years ago. By 74,000 years ago, we had already begun to spread. Small groups of sapiens lived in the Middle East, possibly in India, maybe even reached Australia, though the exact dates are still debated. Archaeological evidence is sparse and often contradictory, but most Homo sapiens still remained in Africa. How many of us were there? Nobody knows for certain. Perhaps 100,000, perhaps 300,000. But this is the critical point. We were not billions. We were not millions. We were tens or hundreds of thousands of people, scattered across a huge continent, living in small, isolated groups that rarely encountered each other. How did they live? These were hunter-gatherers. Small bands, maybe 20 to 50 people, roaming across savannas, forests, and coastlines. They hunted antelope, gazelles, wild cattle. They gathered plants, roots, fruits, nuts. They fished in rivers and along coasts. Their tools were made of stone, hand axes, scrapers, spear points. simple by our standards, but effective. A well-made hand axe could butcher an animal, cut wood, dig for roots. It was a multi-purpose tool that required skill and knowledge to create. They had fire. This was enormous. Fire provided warmth, protection from predators, a way to cook food and make it more digestible. Fire was the center of social life. Around the campfire, stories were told, knowledge was passed down, bonds were formed. Fire made the night less dangerous. It allowed humans to extend their activity beyond daylight. It was transformative technology, as important to them as electricity is to us. They had language. How complex? We do not know for certain, but genetic and anatomical evidence suggests they could speak. The FOXP2 gene, associated with speech, was already present. The anatomy of their throats allowed for complex sounds. Language means culture. It means the ability to plan, to coordinate hunts, to pass knowledge across generations. Language is what makes us human. It allows us to share what is not physically present, to talk about the past and future, to teach and learn. Without language, none of what we are would be possible. They created art. In Africa, ochre engravings 100,000 years old have been found. Beads made from shells, symbols. All of this points to symbolic thinking, to the ability to imagine something that is not directly in front of you. This means imagination, abstract thought, culture. These people were not primitive in their minds. They thought, felt, dreamed, feared, loved, just as we do. But life was incredibly hard. Average life expectancy was probably around 30 years. Child mortality was huge. Diseases, predators, starvation, injuries, all could kill at any moment. There was no medicine, no antibiotics. Even a simple infection could be fatal. A broken bone might mean death. Childbirth was dangerous for both mother and baby. The climate was unstable. The Ice Age did not just mean cold. It meant droughts. It meant changing vegetation patterns. Animals migrated. Food sources disappeared and reappeared. Survival required flexibility, knowledge, the ability to adapt. Groups that could not adapt died out. Those that could survived and passed on their knowledge. And in this world, full of dangers and uncertainty, on the other side of the planet, on an island we now call Sumatra, deep underground, a massive magma chamber was building, growing. Pressure was increasing, and soon it would explode with a force that would change the entire planet. But the people living their lives 74,000 years ago had no idea. They woke up each day, hunted, gathered, cared for their children, told stories, and went to sleep, completely unaware that a catastrophe beyond their imagination was about to occur. This was the world before TOBA, a world of small human populations clinging to existence, a world where every day was uncertain, a world where humanity was just one species among many, not yet dominant, not yet certain to survive, a world on the edge, and that world was about to be shattered. Let me paint a more detailed picture of daily life in this world, because it is important to understand what was at stake. What would be lost if these populations did not survive? A typical day for a human group 74,000 years ago began at dawn. The night was dangerous. Predators were active. Lions, leopards, hyenas. Sleeping safely required choosing good locations, perhaps caves or rocky overhangs, and maintaining fires. Fire was crucial. As the sun rose, the group would wake. Women and older children might gather plant foods, fruits, nuts, roots, tubers. These provided reliable calories, though they required knowledge of what was edible and what was poisonous. Men typically hunted, though women sometimes participated too. Hunting required coordination, planning, knowledge of animal behavior. Small game could be caught with traps or thrown stones. Larger game required group effort, driving animals toward cliffs or into ambush locations, using fire to control movement. This was dangerous work. A cornered animal could kill. An injured hunter might not survive, but the rewards were worth it. Meat provided protein and fat, essential nutrients that plant foods alone could not supply. Toolmaking was a constant activity. Stone tools dulled with use. They needed to be resharpened or replaced. Making a good hand axe required skill. You had to understand the properties of different types of stone. You had to know how to strike at the right angle. A master toolmaker was valuable to the group. Their knowledge was passed down through generations, refined and improved. This was technology. This was culture. This was human. Lake Toba. If you look at a modern map of Indonesia, on the island of Sumatra, you will see a massive lake, 100 kilometers long, 30 kilometers wide, up to 500 meters deep. It is the largest volcanic lake on Earth, and it is beautiful. Tourists come here to admire the views, swim in the clear water, visit traditional Batak villages. It is a peaceful, serene place. But this lake is a scar. A scar from one of the most powerful eruptions in Earth's history. 74,000 years ago, there was no lake here. There was a mountain, a volcano, and beneath it, several kilometers down, was a gigantic magma chamber filled with molten rock. Magma had been accumulating for thousands of years. Pressure was building. The chamber was expanding, cracking, filling with more and more molten rock. It was a bomb waiting to explode. What is a supervolcano? It is not a regular volcano. Regular volcanoes erupt frequently, spewing lava and ash. They are dangerous, but locally, a supervolcano is different. It is a catastrophic eruption that can eject more than 1,000 cubic kilometers of material. For comparison, the eruption of Vesuvius that destroyed Pompeii ejected about 3 cubic kilometers. The eruption of Krakatoa in 1883 ejected about 20 cubic kilometers. These were massive, deadly events. Toba ejected approximately 2,800 cubic kilometers of material. That is roughly 140 times more than Krakatoa, 1,000 times more than Vesuvius. It was a disaster of planetary scale. To put this in perspective, imagine taking all the material from the Grand Canyon and launching it into the atmosphere. That is roughly the amount of material Toba ejected. It is almost incomprehensible. How did scientists discover this? The first clue was the lake itself. Its shape, its size, its geology, all pointed to it being a caldera, a massive hole formed when the ground collapsed after an eruption. In the 1970s, geologists began studying ash found in sediments across South and Southeast Asia. The chemical composition of this ash matched the Toba volcano. This was the smoking gun, literally. The Toba ash layer was found in India, up to 6 meters thick in some places. Imagine, you are standing in the middle of India, 3,000 kilometers from Sumatra, and 6 meters of volcanic ash falls on top of you. This is not just a layer of dust. This is a thick, heavy blanket of hot material that would suffocate everything living. Plants die, animals die. The land becomes barren. Water sources become contaminated. The ecosystem collapses. Ash reached Africa. Tiny particles of Toba ash were found in marine sediments off the coast of East Africa, in China, in the Arabian Sea. The eruption covered most of Asia with a layer of ash, and ash in the atmosphere spread around the entire world. This was not a regional event. This was global. Every living thing on Earth was affected in some way. Dating the eruption was done using radiometric methods, analyzing isotopes in the ash and volcanic rocks. The result? 74,000 years ago, give or take a few thousand years. This coincides with the period when geneticists see signs of a sharp decline in human population. Coincidence? Or causal connection? This is what scientists are still debating. To understand the scale, let us compare with other known eruptions. The Yellowstone eruption, 640,000 years ago, was a supervolcanic event that ejected about 1,000 cubic kilometers of material. Toba was almost 3 times more powerful. The eruption of Mount Pinatubo in the Philippines in 1991, which lowered global temperatures by half a degree for several years, ejected just 10 cubic kilometers. Toba was 280 times stronger. The Mount Street, Helen's eruption in 1980, which seemed devastating at the time, ejected 1 cubic kilometer. Toba was 2,800 times larger. Supervolcanoes do not erupt often. That is good news. Bad news. When they do erupt, the consequences are global. In Earth's geological history, there have been several such events. Most occurred millions of years ago. TOBA is the most recent supervolcanic eruption in our species' history. There has not been anything like it since. We have no modern experience with such an event. Everything we know comes from studying the evidence it left behind. Why did it explode exactly then? Chance. Volcanoes do not follow schedules. Magma accumulates. Pressure builds. At some point, the rock can no longer contain it. A crack expands. Gases escape, and the cataclysm begins. There was nothing special about that moment. It could have happened 1,000 years earlier, or later, but it happened then, and the timing would prove crucial for humanity. For the people living 74,000 years ago, it was just another day. They did not know about supervolcanoes. They did not know that on the other side of the world, disaster was building. They hunted, gathered, raised children, told stories around the fire. And then, in one moment, the sky changed, and their world changed forever. Before we describe the eruption itself, we need to understand one more thing. What makes a supervolcanic eruption different from a regular volcanic eruption? Regular volcanic eruptions happen when magma rises through a conduit to the surface. The eruption is relatively controlled, flowing out over time. But in a supervolcanic eruption, the magma chamber itself ruptures. The entire top of the chamber collapses. Gases dissolved in the magma under immense pressure suddenly expand. This creates an explosion. Not a flow, but a blast. And the amount of material ejected is enormous, because you are not just emptying a conduit, you are emptying an entire underground reservoir of molten rock. This is what happened at TOBA. The chamber ruptured, and in that moment, the world changed. Imagine you are living on the coast of Sumatra. The morning began like any other. Sunrise, sounds of the jungle, birds singing. Your group is preparing for the day. Men are checking spears for hunting. Women are gathering fruits. Children are playing by the water. A normal day in the life of Homo sapiens 74,000 years ago. The air is warm and humid, typical for this region. The sea is calm. Everything seems peaceful. Then you feel a tremor. The ground shakes. Slightly at first, then stronger. Birds take flight in panic. Animals flee. People look at each other with concern. This is not the first earthquake they have experienced. But this one does not stop. It intensifies. Objects fall. People struggle to keep their balance. The shaking goes on for minutes. This is not normal. And then, the explosion. Not just a sound. It is pressure. It is a shockwave that hits your chest, your ears. It is the loudest sound any living thing in that part of the world has ever heard. Louder than thunder. Louder than anything in human experience. The sound travels hundreds of kilometers. People thousands of kilometers away hear it as a distant roar, like continuous thunder that does not stop. You look north and see a column. A massive column of smoke, ash, and superheated rock rising into the sky. It grows, expands, blots out the sun. The sky darkens. Not gradually, quickly. Within minutes, day turns to twilight. Within an hour, into night. A darkness deeper than any night you have known. Because this is not just the absence of sunlight. This is a sky filled with ash and debris, blocking every ray of light. The eruption of TOBA was a Plinian eruption. This means explosive in character. When the magma chamber breached, gases dissolved in the magma under enormous pressure instantly expanded. Imagine a bottle of champagne, but 1 billion times more powerful. Magma was ejected upward at speeds of hundreds of meters per second. The force was unimaginable. The violence was total. The eruptive column, the pillar of material rising from the volcano's vent, reached a height of 30 to 40 kilometers. That is higher than modern aircraft fly. That is in the stratosphere. At this height, material spreads horizontally, forming a massive mushroom cloud, similar to a nuclear explosion, but many times larger. The column was so tall, that it penetrated through the troposphere, where weather happens, into the stratosphere, where particles can remain for years. What happens next? Pyroclastic flows. These are deadly avalanches of superheated gas, ash, and rock fragments racing down the volcano's slopes at speeds up to 700 kilometers per hour. Temperature inside, from 200 to 700 degrees Celsius. Nothing living can survive them. They burn, suffocate, bury everything in their path. Trees are incinerated instantly. Animals have no chance. Any human within reach is killed in seconds. The pyroclastic flows from TOBA spread for tens of kilometers from the caldera. They filled valleys. They overtopped hills. The entire area around the volcano was sterilized. Every plant, every animal, every human within hundreds of kilometers died instantly. This was ground zero. Nothing survived. The landscape was transformed into a gray wasteland of volcanic deposits, still hot, completely lifeless. But the eruption did not stop there. It continued for days, maybe weeks. The magma chamber was emptying. 2,800 cubic kilometers of magma turned into ash, pumice, volcanic bombs. Material was ejected into the atmosphere. Winds carried it around the world. And as the chamber emptied, the weight of the ground above lost support. The roof of the chamber collapsed. And this created the caldera, the massive hole that would eventually fill with water and become Lake Toba. Ash fell over vast areas. In India, 3,000 kilometers away, the ash layer accumulated for meters. In Malaysia, Thailand, throughout Southeast Asia, the ground was covered with gray, dead material. It smothered plants. It contaminated water. It buried entire ecosystems. Imagine waking up one morning to find your world covered in thick ash. You cannot see the sun. You cannot breathe properly. Every water source is polluted. Every plant is dying. What do you do? Where do you go? And tsunamis. When the magma chamber emptied and the ground above collapsed, forming the caldera, this collapse was so massive it triggered mega tsunamis. Waves tens of meters high swept across the Indian Ocean, striking the coasts of India, Africa, Arabia. For coastal populations of humans, this was an additional catastrophe. Those who survived the initial ash faced giant waves that washed away camps, flooded lowlands, changed coastlines. Survival on the coast became nearly impossible. Imagine being a coastal group. You see the darkness. You experience the ashfall. Your water sources are poisoned. Your food sources are dying. And then a massive wave comes. You have nowhere to go. You have no warning system. You have no understanding of what is happening. You just know that the world has gone mad, that everything you knew has been destroyed, that survival is now the only thing that matters. But the worst was yet to come. The ash in the atmosphere was just the beginning. Billions of tons of sulfur were ejected into the stratosphere. Sulfur combined with water, forming sulfuric acid. These tiny droplets of sulfuric acid formed an aerosol layer that enveloped the entire planet, and this layer reflected sunlight back into space. Less sunlight reached Earth's surface. Temperatures began to drop, rapidly, globally. This was not a local catastrophe. This was a global climate catastrophe. For people living in Africa, thousands of kilometers from the eruption, the first sign was the change in the sky. The sun became dim, reddish. Sunsets became strange, blood red. Then came the ash, a thin layer of gray dust covering everything. And then, the cold. Temperatures that had been warm became cool. Seasons changed, rains failed, or came at wrong times. The world became unpredictable. For populations in Asia, closer to the eruption, the effects were catastrophic. Thick ash destroyed vegetation. Animals could not find food. Predators starved. Herbivores died. The entire food chain collapsed. Humans, dependent on hunting and gathering, faced an impossible choice: migrate or die. But migrate where? The disaster was everywhere. There was no safe haven close by. The ash covered everything. How many people died immediately? We will never know. But it was tens of thousands, maybe more. Everyone living within 1,000 kilometers of TOBA likely perished, either from the direct effects of the eruption or from starvation that followed as ecosystems collapsed. Entire populations vanished. Entire groups were wiped out. The genetic diversity they carried was lost forever. But the eruption was just the beginning. The real nightmare started afterwards. When the ash settled, when the aerosols spread, when temperatures began to drop, because what came next was not just an eruption, it was a volcanic winter. A period of cold and darkness that would test humanity to its very limits. A time when survival was not certain. A time when our species came as close to extinction as it has ever been. This is when the story becomes not just about a volcano, but about human resilience, about our ability to adapt, about our determination to survive against impossible odds. Because those who lived through this, those who found a way to endure, they are the reason we exist today. Without them, there would be no us. This is their story. This is our origin story. This is the moment that forged humanity. A volcanic winter is what happens when enormous amounts of ash and aerosols enter the stratosphere and block sunlight. It is similar to nuclear winter, a concept you may have heard about in the context of nuclear war. But the TOBA eruption was a natural event, and it was real. The volcanic winter that followed the TOBA eruption may have been the most severe climate catastrophe humanity has ever faced. How does it work? Sunlight is the source of all energy on Earth. Plants use it for photosynthesis. Animals eat plants. Predators eat animals. All life depends on the sun. When you block sunlight, you disrupt the entire system. Photosynthesis slows. Plants grow less. Some die. Herbivores have less food. They weaken. They die. Predators have less prey. They starve. The entire ecosystem cascades into collapse. The sulfur aerosols from TOBA remained in the stratosphere for years. Some models suggest 3 to 5 years. During this time, they reflected a significant portion of sunlight back into space. How much? Estimates vary, but possibly 10 to 20% of solar radiation was blocked. That might not sound like much, but it is enormous. The difference between an ice age and a warm period is only a few degrees of average temperature. Blocking even 10% of sunlight can cause dramatic changes. What does this mean for temperature? Climate models run by scientists suggest global average temperatures dropped by 3 to 5 degrees Celsius. That is the average. In some regions, the drop was much more extreme. In the tropics, where most early humans lived, temperatures may have fallen by 10 to 15 degrees. 10 degrees does not sound like much, but it is huge. Imagine your climate instantly changing to the climate found 1,000 kilometers north. Plants adapted to tropical heat cannot survive. They wither. They die. Forests turn to scrubland. Savannas turn to deserts. And it is not just temperature. Precipitation changed. Eruptions affect atmospheric circulation. Monsoons, on which millions of square kilometers of Asia and Africa depend, were disrupted. Some regions became drier. Droughts spread. Rivers dried up. Lakes shrank. Water, the most essential resource, became scarce. Without water, there is no life. Without reliable water sources, human populations could not survive. In India, where the thickest layer of ash fell, the effects were catastrophic. 6 meters of ash covered large areas. This ash was not just an inconvenience, it was toxic. It polluted water sources. It made soil infertile. Plants could not grow. Animals could not find food. The ecosystem collapsed completely. For any human populations in this region, survival became nearly impossible. They either migrated or perished. Archaeological evidence from India shows a sharp change around 74,000 years ago. Middle Paleolithic stone tools, which were common before the eruption, almost disappear. Then, after several thousand years, new types of tools appear. This suggests that populations either died out or were displaced, and new groups migrated in later. There is a gap, a silence in the archaeological record. And silence in archaeology usually means absence of people. In Southeast Asia, the situation was even worse. This was the epicenter. Layers of ash, pyroclastic deposits, tsunamis. Some scientists believe that Homo sapiens in this region, if they were there at all, were completely wiped out. No group could have survived such a catastrophe. The land was completely transformed. It would take thousands of years for ecosystems to recover. What about Africa? This is the key question, because Africa is where most humans lived. If the TOBA eruption really nearly wiped out humanity, then we should see evidence in Africa. And we do, though it is complex. Climate data from Africa shows a period of extreme drought around the same time as the TOBA eruption. Lake Malawi, one of Africa's Great Lakes, has sediment records showing a sharp drop in water level. Other lakes also shrank. This indicates a much drier climate. Drier means less vegetation. Less vegetation means fewer animals. Fewer animals means less food for humans. Hunter-gatherers depend on the abundance of nature. When nature fails, people starve. And in a severe drought lasting years, starvation becomes widespread. Populations shrink. Groups die out. Only those in the most favorable locations survive. Some models suggest that human populations in Africa declined by 90% or more. 90%. If there were 100,000 people before the eruption, only 10,000 remained. If there were 200,000, only 20,000 remained. These numbers are theoretical, based on climate models and genetic data, but they suggest a catastrophe of incredible scale, a die-off so severe that it left a permanent mark in our DNA. How long did the volcanic winter last? The aerosols remained in the atmosphere for several years, but the climate effects lasted longer. Earth does not recover instantly. Ecosystems need time to rebuild. Soil needs time to wash out toxins. Forests need time to regrow. Some scientists believe recovery took decades. Others say centuries. The truth is probably somewhere in between. But for the people living through it, time did not matter. Every year was a struggle. Every season was uncertain. Survival was not guaranteed. Imagine a child born just after the eruption. All this child ever knew was a world of scarcity. Cold winters, dry summers, stories about before times, when food was more abundant, when the sky was brighter, when life was easier. But those stories seem like myths. This child grows up in a harsh world, learns to hunt, to gather, to survive with less, finds a partner, has children, and tells them stories about how the world was once different, and the cycle continues. But in these stories, there is no record of the eruption, no memory of the blast, because those who witnessed it either died or were too young to understand. For subsequent generations, the changed climate was just how the world was. They did not know the cause. They did not know about a volcano on the other side of Earth. They just knew that life was hard, and survival required all their skills and luck. Where did people survive? Probably in refugia, protected areas where conditions remained tolerable, coastal regions with reliable seafood, river valleys with permanent water, caves in mountains, areas with microclimates that buffered against the worst effects. These refugia became the cradles of survival, small populations clinging to existence in isolated pockets. And here is something important. These refugia were not just places of survival, they were places of adaptation. Humans in these isolated groups developed new strategies, new tools, new ways of thinking. When you are pushed to the edge, innovation becomes necessary. You cannot rely on what worked before. You have to experiment. You have to try new things. And those who succeeded in finding new solutions were the ones who survived. Some scientists believe that the TOBA bottleneck forced humans to become more innovative, that the crisis triggered a cognitive leap, that the pressure of near extinction selected for intelligence, creativity, cooperation. This is speculative, but there is some evidence. Around this time, we see changes in stone tool technology. We see more sophisticated hunting strategies. We see the beginnings of long-distance trade networks. As if the crisis forced humanity to level up. This was a time when humanity was tested, not by war, not by disease, but by nature itself. The planet threw a challenge at our species. And the question was simple: can we survive? And if so, how many of us? The answer to that question is written in our DNA, and that is what we will explore next. Now we move to one of the most fascinating and controversial aspects of the TOBA story: genetics. Because if the eruption really almost wiped out humanity, our DNA should show it. And it does. Sort of. The evidence is there, but interpreting it is complex. This is where science becomes both powerful and frustrating. Powerful because genetics gives us a window into the past that archaeology alone cannot provide. Frustrating because genetic data requires careful interpretation and can support multiple scenarios. Let us start with basics. Every time a human is born, tiny mutations occur in their DNA. These mutations are random and usually harmless. They accumulate over time. By comparing DNA from different people, geneticists can estimate how much time has passed since their ancestors diverged. This is called the molecular clock. It is not perfect, but it is a powerful tool. The more mutations differ between two people, the longer ago their ancestors separated. The fewer differences, the more recently they shared a common ancestor. When geneticists began studying DNA from people around the world, they discovered something strange. We are too similar. Compare humans to chimpanzees. Chimpanzees have much more genetic diversity than humans, even though their population is much smaller than ours. Why? Because chimpanzees evolved without any major population crashes. Their genetic diversity accumulated steadily over millions of years. Different chimpanzee groups have been separated for long periods, allowing different mutations to accumulate. Humans? Our genetic diversity is low, so low that geneticists proposed that at some point in our history, our population must have crashed dramatically. This is called a genetic bottleneck. The population becomes so small that much of the genetic diversity is lost, and only a limited set of genes gets passed on to future generations. Everyone alive today inherited genes from that small surviving group. When did this bottleneck occur? Analysis of mitochondrial DNA, which is passed from mother to child, suggests it happened roughly 50 to 100,000 years ago. The Y chromosome, which passes from father to son, shows a similar pattern. All of humanity traces back to a small number of ancestors living during this period. We call the most recent common female ancestor mitochondrial Eve. The most recent common male ancestor is Y chromosomal Adam, but these are not individuals. They are markers in time, representing populations that survived. How many people? Genetic estimates vary widely. Some studies suggest as few as 3 to 10,000 breeding individuals. Other studies suggest more, maybe 15 to 20,000, but even the upper estimate is incredibly small. For context, today there are about 8 billion people. 74,000 years ago, there may have been just a few thousand. That is not just a small town. That is several small villages. That is all of humanity fitting into a single modern sports stadium. And the timing of this bottleneck roughly coincides with the TOBA eruption. This is what led some scientists, like Stanley Ambrose, who first proposed the TOBA catastrophe hypothesis in 1998, to conclude that the eruption caused the population crash. The logic is straightforward. TOBA erupted. Volcanic winter ensued. Ecosystems collapsed. Human populations crashed. Only small groups in refugia survived. Over time, as climate recovered, these groups expanded and repopulated the world, and all of us descend from those survivors. This is an attractive hypothesis. It is dramatic. It fits the genetic data. It explains why we are all so genetically similar. But is it correct? This is where the debate begins. Some geneticists say maybe. The bottleneck is real. The population crash happened. But was it caused by TOBA? Or was it caused by something else? Climate was unstable during this period for many reasons. The Ice Age itself created harsh conditions. TOBA may have been just one factor among many. Other geneticists say the timeline is too uncertain. Genetic dating is not that precise. It gives a range, not a specific date. The bottleneck could have occurred 10,000 years earlier or later. The coincidence with TOBA may be just that, a coincidence. This is a critical point. Genetic clocks have error bars. When we say the bottleneck occurred 74,000 years ago, we really mean it occurred sometime between 60 and 90,000 years ago, depending on assumptions about mutation rates. And another point, a bottleneck does not necessarily mean the species almost went extinct. It just means most of the genetic diversity was lost. This could happen if a small group migrated out of Africa and founded all non-African populations. That group would be genetically less diverse than the entire African population, even without a catastrophe. This is called the founder effect. When a small group colonizes a new area, they carry only a subset of the genetic diversity from the source population. So genetics does not give a definitive answer. It tells us that at some point, the human population was small. It tells us we are all closely related, but it does not tell us why. For that, we need to look at other evidence. We need to combine genetics with archaeology, with climate science, with geology. Only by putting all the pieces together can we get a complete picture. One interesting piece of genetic evidence is the distribution of diversity. African populations have the most genetic diversity. This makes sense because Homo sapiens originated in Africa and lived there longest. But even within Africa, diversity is concentrated in certain regions. East Africa, particularly the area around Ethiopia and Kenya, shows the most diversity. This suggests this area may have been a refugium, a place where populations survived when other areas became uninhabitable. Similar patterns are seen in southern Africa, particularly around the Cape. This is consistent with the TOBA hypothesis. If volcanic winter made much of Africa too dry, populations would have concentrated in areas where there was still water and food, coasts, rivers, areas with more stable microclimates. These refugia would have become the hubs of survival. And after climate improved, populations in these refugia expanded. They migrated, recolonized the emptied areas, eventually moved out of Africa and spread across the world. All non-African populations descend from these expansions. Another genetic clue comes from Neanderthals. We know that Homo sapiens and Neanderthals interbred. Most non-Africans have about 1 to 2% Neanderthal DNA. When did this happen? Genetic analysis suggests interbreeding occurred around 50 to 60,000 years ago, when sapiens migrated out of Africa into the Middle East and encountered Neanderthals. This is after the TOBA eruption. If TOBA really almost wiped out humanity, then the migration out of Africa was part of the recovery, the recolonization of the world by a small group of survivors, and Denisovans too. Some populations, especially in Melanesia, have up to 5% Denisovan DNA. Interbreeding with Denisovans also occurred after TOBA. This suggests that after the bottleneck, sapiens expanded, encountered other human species, interbred, and eventually became the dominant species. These other species contributed genes to us, genes that helped us adapt to new environments. Tibetans have a Denisovan gene that helps them survive at high altitude. Melanesians have Denisovan genes related to immune function. These genetic gifts from extinct species may have been crucial for our survival and expansion. But here's an important point. Neanderthals and Denisovans also survived TOBA. They did not go extinct. So if the eruption was so catastrophic that it almost wiped out Homo sapiens, why did it not wipe out other humans? Neanderthals lived in Europe, closer to the pole, where cooling would have been more extreme. Yet they survived another 30,000 years after TOBA. This is a puzzle. One possible explanation. Neanderthals were better adapted to cold. They had stockier bodies, more muscle mass, larger nasal cavities to warm cold air. They had been surviving in Ice Age Europe for hundreds of thousands of years. They knew how to handle cold. Sapiens, mostly in warmer climates, may have been more vulnerable to sudden cooling. We were tropical people suddenly facing temperate or even subarctic conditions. We were not prepared. But this is speculation. The truth is, we do not know exactly how different populations responded to the eruption. Maybe some were more affected than others. Maybe local conditions mattered more than global climate. Maybe some groups had access to resources that others did not. The picture is complex, and this is why scientists continue to debate. Recent genetic studies have added new layers to this debate. Whole genome sequencing of ancient DNA, when available, gives us more detailed information about population history. These studies suggest that the bottleneck may not have been quite as severe as once thought. Maybe the population did not drop to just a few thousand. Maybe it was tens of thousands, which is still very small, but not catastrophically so. Maybe the bottleneck was not a single event, but a series of population declines over thousands of years. And here is something fascinating. Genetic diversity in some genes is higher than expected. This suggests that in certain populations, selection was acting strongly, maintaining diversity in genes important for survival. Immune system genes, for example, show more diversity than neutral genes. This makes sense. During a crisis, those with better immune systems survive. Their genes spread. Diversity in these critical genes is maintained even as overall diversity drops. So what does genetics really tell us? It tells us humanity went through a bottleneck. It tells us we are all closely related, descendants of a small ancestral population. But it cannot tell us definitively what caused the bottleneck, or exactly when it happened. For that fuller picture, we need to look at archaeology, at climate records, at the physical evidence of how people lived and died, and that evidence paints a more nuanced picture than simple catastrophe. The TOBA catastrophe hypothesis is one of the most controversial ideas in paleoanthropology. Some scientists fully believe it. Others categorically reject it. Most are somewhere in between. Why so much debate? Because the evidence is ambiguous. Science thrives on debate, on questioning, on challenging ideas. And the TOBA hypothesis has been challenged extensively. Let us look at both sides. Start with the supporting evidence. We have the eruption itself, which is undeniable. We have ash layers across Asia. We have climate models showing significant cooling. We have genetic evidence of a bottleneck. All of this is consistent with the idea that TOBA nearly wiped out humanity. The pieces seem to fit together. A massive eruption, a volcanic winter, a population crash. It makes sense. It is a compelling narrative. But now let us look at contradictory evidence, and there is plenty of it. First, archaeology. If TOBA caused mass extinction, we should see a sharp change in the archaeological record. Settlements should disappear. Tool types should change. There should be a gap, a discontinuity. And in some places we see this. In India, as I mentioned, there are changes. Tool assemblages shift. But in many other places, continuity. Archaeological sites in Africa dated before and after TOBA show similar tool types, similar behaviors, similar patterns. No obvious sign of catastrophe. The site at Pinnacle Point in South Africa was occupied before, during, and after the TOBA eruption. TOBA ash layers were found right in the sequence, but human activity continued. People did not abandon the site. They did not significantly change their tools. Life went on. This is important. If the eruption caused near extinction, we should see abandonment, change, crisis. But we do not. At least not everywhere. Similar patterns are seen at other African sites. Diepkloof Rock Shelter, Clazy's River, Blombo's Cave. These sites span the TOBA period, and they show continuity. Yes, there are some changes. Climate was shifting. Resources were changing. But no collapse, no die-off. People adapted, they continued. This suggests that while the eruption was huge, its impact on African populations may not have been as catastrophic as once thought. Maybe local conditions varied. Maybe some areas were protected. Maybe humans were more resilient than we think. Second contradiction, climate data. While models predict significant cooling, direct evidence from ice cores and ocean sediments is less clear. Some studies show cooling, but not as extreme as models predict. Other studies show minimal impact. Ice cores from Greenland, which provide detailed climate history, do show a change around the time of TOBA, but it is not the biggest change in that period. The Ice Age itself was a time of intense climate variability. There were other cold events, some as severe or more severe than the TOBA period. This has led some scientists to argue that the volcanic winter from TOBA was short, maybe only a few years, and that long-term climate impacts were minimal. If this is the case, then populations would have had a better chance to survive. A few bad years are tough, but survivable. A few decades of cold and drought? That is catastrophic. The question is, which scenario is correct? And the answer is, we are still not sure. Third contradiction, other human species. Neanderthals and Denisovans survived TOBA. If the eruption was so catastrophic that it nearly wiped out Homo sapiens, why did it not wipe out other humans? Neanderthals lived in Europe, closer to the pole, where cooling would have been more extreme. Yet they survived another 30,000 years after TOBA. Denisovans in Asia also survived. If TOBA was an extinction-level event, how did these populations make it through? Possible explanation: they were better adapted. Neanderthals had more cold-adapted bodies. Denisovans lived in mountainous regions where they were already dealing with harsh conditions. Maybe sapiens, being more tropical, were more vulnerable. Or maybe the impact of TOBA was not uniform. Maybe Europe and Northern Asia were less affected than the tropics. Climate models are global averages. Local conditions can vary significantly. Maybe some regions got lucky. Fourth contradiction, genetic uncertainty. While the bottleneck is real, its cause is not certain. The bottleneck could have been caused not by a single event, but by a series of climate stresses over thousands of years. TOBA may have been part of this, but not the only cause. The Ice Age itself created harsh conditions that lasted for tens of thousands of years. Populations were already under pressure. TOBA may have been the straw that broke the camel's back, but not the only burden the camel was carrying. Some geneticists also argue that the bottleneck may not have been as extreme as once thought. New analytical methods suggest the population may have declined, but not to just a few thousand. Maybe it was tens of thousands, which is still small, but not catastrophically so. And maybe the bottleneck was not a single sharp event, but a longer period of low population, a slow decline rather than a sudden crash. So where is the truth? Honestly, we still do not know. The TOBA catastrophe hypothesis remains exactly that, a hypothesis. It is a plausible explanation that fits some evidence, but not all. Science requires more data, more excavations, more analysis before we can say with certainty. And this is how science works. We propose ideas, we test them, we refine them, we argue about them, and slowly, over time, we get closer to truth. What we know for certain: the TOBA eruption was one of the largest volcanic events in the past 2 million years. It affected climate. It ejected enormous amounts of ash. It changed ecosystems. The question is how much it affected human populations. Did it nearly wipe us out? Or was its impact more limited? Both scenarios are possible. Both fit some of the evidence. Some scientists now prefer a more moderate version of the hypothesis. They suggest that TOBA did not cause near extinction, but did cause significant population decline, especially in Asia. African populations, being farther from the epicenter, may have been less affected. This moderate version acknowledges that the eruption was a serious event, but not an existential threat. It fits the archaeological data showing continuity in many areas, while still recognizing the genetic bottleneck. Another perspective: maybe TOBA was not about nearly wiping us out, but about changing us. Maybe the crisis forced innovation. Maybe the survivors were those who could adapt, who could think creatively, who could cooperate more effectively. Maybe TOBA selected for the traits that would later allow humans to dominate the planet. This is speculative, but interesting. Sometimes pressure creates diamonds. Maybe pressure created us. The debate continues. New excavations find new sites. New genetic studies refine the timeline. New climate models improve precision. Each piece of evidence adds to our understanding. And over time, maybe we will get a clear picture of what really happened 74,000 years ago. Until then, we live with uncertainty, and that is okay. Science is comfortable with uncertainty. It is better to admit we do not know than to claim false certainty. What matters is that we keep asking questions. We keep looking for evidence. We keep testing ideas. Because understanding our past helps us understand ourselves. It tells us where we came from. It tells us what we are capable of surviving. And it tells us that even in the face of catastrophe, humanity endures. So what have we learned? 74,000 years ago, one of the most powerful volcanic eruptions in recent geological history occurred on our planet. The TOBA eruption released thousands of cubic kilometers of material into the atmosphere, covered Asia with layers of ash, and triggered a volcanic winter that affected climate worldwide. This is documented fact. The evidence is extensive. We have also learned that around the same time, the human population went through a genetic bottleneck. Our population decreased, possibly dramatically. All of humanity today descends from a relatively small group of ancestors living during this period. This is well established. The genetic evidence is clear. We are all closely related, more closely than most species. We are, quite literally, family. Was the TOBA eruption the cause of this bottleneck? It likely played a role. But was it the only cause? Possibly not. Climate was unstable for many reasons. The Ice Age created harsh conditions. Human populations may have already been under pressure before the eruption. TOBA may have been a crisis on top of existing difficulties, or it may have been the main driver. We cannot say for certain. The honest answer is probably a combination of factors. But regardless of the exact cause, one thing is clear. Our species survived a moment of great vulnerability. We faced significant challenges, and the fact that we are here today, 8 billion strong, spread across every continent, is a testament to the resilience of those ancient ancestors. They persevered. They found ways to survive. They adapted. They endured. Think about this. Those few thousand people, whoever they were, wherever they were, survived. They faced climate change, food scarcity, drought, and cold. And they continued. They had children. They passed down knowledge. They adapted. And every one of us carries their legacy. Every person on Earth, no matter where we live, what we look like, what language we speak, we all descend from those survivors. We are their descendants. Their genes are in our DNA. Their resilience is in our capacity to adapt, to survive, to thrive. This is a profound connection. It tells us we are all family. Literally, our differences are superficial. Beneath them, we are all closely related, more than almost any other species on Earth. This is the legacy of the bottleneck. We all came from a small group, and this makes us kin. In a world often divided by nationality, culture, and beliefs, this is worth remembering. We are one species, one family, one humanity. But there's also another lesson. The TOBA story reminds us how fragile our existence is, how vulnerable we are to natural forces. A supervolcano could erupt again. Yellowstone, Campi Flegrei in Italy, others. We cannot predict them with certainty. We cannot prevent them. And volcanoes are not the only challenge. Climate change, asteroids, pandemics, all these things could, in principle, test humanity just as TOBA may have done 74,000 years ago. The difference is that now we are 8 billion. We have technology, we have knowledge, but we also have the ability to create risks that our ancestors could not imagine. We have created challenges that did not exist before. The question is, will we use our technology wisely? Will we prepare for potential threats? Will we cooperate as a species to ensure survival? Perhaps the TOBA story is not just about the past. It is a reminder about the future. A reminder that survival is not guaranteed. That every generation must face the challenges of its time. That our resilience as a species depends on our ability to work together, to adapt, to plan ahead. Those ancient humans, standing around fires 74,000 years ago, did not know about supervolcanoes. They did not understand climate science, but they understood survival. They understood cooperation, and that is what saved them. Not technology, not weapons, but community, family, culture. The ability to adapt, to learn, to work together. These things are as important today as they were then. Maybe more important, because the threats we face now are not just natural. Many are of our own making, and solving them requires the same qualities that saved our ancestors: cooperation, innovation, determination. So, was TOBA nearly the end of humanity? Maybe, maybe not. Science is still working it out. But regardless of the exact answer, the story tells us something important. We survived. Against all odds, through incredible hardship, our species continued. And that, in itself, is remarkable. Every breath you take, every thought in your head, every connection you form, all of it is possible because a small group of people, 74,000 years ago, refused to give up. They faced the end of their world and found a way to survive. And their survival gave us life. We are their legacy. We are living proof that humanity can endure even the darkest times. And if we can remember this, if we can learn from them, maybe we too can face the challenges of our time and leave a world that allows future generations to thrive. That is the story of TOBA, a story of fire and ash, of survival and resilience, of how close we came to never existing, and of why each of us here today is a miracle. Let me leave you with one final thought. The TOBA story, whether it was a near extinction event or simply a severe crisis, teaches us something profound about human nature. We are survivors. Not because we are the strongest, or the fastest, or the most physically powerful, but because we can think, we can plan, we can cooperate, we can pass knowledge from one generation to the next. We can look at a problem and figure out solutions. These are the traits that saved our ancestors. These are the traits that define us as a species. In an age of artificial intelligence and space exploration, it is easy to forget our origins, to forget that we are biological creatures who evolved on this planet through millions of years of natural selection, to forget that our brains, our bodies, our emotions were all shaped by the need to survive in a challenging world. TOBA reminds us of this. It connects us to our deep past. It shows us where we came from. And understanding where we came from helps us understand where we might go. The survivors of TOBA had no idea that their descendants would one day build cities, write books, create art, explore space. They were just trying to make it through another day, to find food, to keep their children alive, to pass on their knowledge. But their struggle, their determination, their refusal to give up, that created the possibility of everything that came after. Every civilization, every achievement, every moment of human joy and triumph. All of it traces back to those survivors who refused to let our species die. So when you look at the night sky and marvel at the stars, remember TOBA. When you hold your child and feel that connection across generations, remember TOBA. When you face challenges in your own life and wonder if you can overcome them, remember TOBA. Because if our ancestors could survive that, if they could endure volcanic winter and drought and starvation and still continue, then we too can face whatever challenges come our way. We carry their strength in our genes. We carry their determination in our culture. We carry their legacy in everything we are. And that is a powerful thing. That is something worth remembering. That is the true meaning of TOBA. Thank you for joining me on this journey back through time. Thank you for caring about where we came from. Because only by understanding our past can we hope to build a better future. The story of TOBA is not finished. We are still living it. We are still writing it. And what we do today will determine whether future generations, 74,000 years from now, look back at us with the same wonder and gratitude that we feel toward those ancient survivors. Will they marvel at how we overcame our challenges? Will they be grateful that we chose cooperation over conflict, wisdom over ignorance, survival over short-term gain? That is up to us. That is our story to write. And it begins with understanding where we came from. It begins with TOBA.